In this video, we will learn about Executor framework in Java, its advantages, the classes and interfaces that belong to it, and how to use it with examples. By the end of this video, you will be able to use it with confidence. Executor framework was introduced in Java 5 to ease writing multi-threaded applications. All the classes that belong to Executor framework belong to java.util.concurrent package. It provides many benefits as compared to traditional Java threads, such as separates tasks from thread creation. We do not have to create threads ourselves, we just have to provide it the task to perform. It manages thread creation and task execution itself. It has a built-in support for thread pooling. All we need is to create a pooled executor and submit the task. The executor service will take care of rest. With conventional thread, there is no way to return a value from a thread. This is because the run method of runnable interface, which is responsible for executing a task in a new thread, has a return type of void, which means that it cannot return a value. Executor framework introduces two new interfaces, callable and future, using which a thread can return a value. We will see that later in the video. At the top of Executor framework is Executor interface, which provides a way to decouple tasks from thread execution with its execute method. Next is the Executor service interface, which provides methods for thread management, such as submit to get a value from thread, killing threads using shutdown and shutdown now methods, etc. This interface extends Executor. There are classes that implement Executor service, such as thread pool executor for executing tasks in a pool, schedule thread pool executor for executing tasks repeatedly and in a certain time interval. Creating objects of these classes is not straightforward. You need to provide a lot of details. For example, look at the constructors of thread pool executor. The simplest constructor takes this much arguments. There is core pool size, max size, keep alive time, etc. Other constructors take more parameters. To simplify creating objects of these classes, the framework provides a utility class, executors, which contains static methods to create objects, such as new single thread executor to create an executor service consisting of a single thread, new fixed thread pool to create a pool of threads, etc. All these methods return an object of executor service. Look, new fixed thread pool internally calls the complicated constructor that we just saw. Alright, let's start with using Executor framework practically. The first step is to create an object of executor. As we saw in the earlier slide, executors class is used for this. So, executors.new single thread executor. This will create a single thread, as you can see here, and should be used when the number of tasks are lesser and need not be executed concurrently. Assign this to a variable of type executor. Now, to create a new thread and perform a task, call its execute method. Execute takes an argument of type runnable. So, create a new class that implements runnable. We need to override its run method. The code written in run will be executed in a new thread. For now, just print the name of the thread which executes this method. Provide an object of this class to execute. Run this. See, this task is executed by a new thread whose name is pool1 thread1. Now, as I said, single thread executor creates only one thread. To show this, let's execute 5 different tasks by putting execute in a loop. Run this. Look, all the tasks are executed by the same thread. A downside of this approach is that the next task will only execute when the previous task has completed. So, actually, you are not getting the advantage of multithreading. To solve this, we need to have a thread pool having multiple threads. Executor framework provides a built-in thread pool functionality. All you need to do is to create an executor having this feature using its new fixed thread pool method, providing it the number of threads that should be present in the pool. Let's test it with 2 threads. Now, we have 2 threads running the task. Let's try with 3 threads. It created 3 threads. When all the threads are busy, new tasks are added to a waiting queue. As the threads become free, they pick up tasks from the queue. When a thread becomes free and there are no other tasks, it goes back to the pool waiting for the next task. Which thread will execute which task is not defined. Threads are chosen at runtime dynamically. How many threads should be created in a pool depends on the requirement of your application and the concurrency level you want to support. If you are using Java version 8 or above, then you can write the implementation of run method as a Lambda expression. If you are not familiar with the Lambda expression, do watch the video that is suggested at the top right corner. Since run method does not return a value, its lambda will be empty parenthesis followed by an arrow and the print statement. This can be directly assigned to a runnable type. Now, we can pass this here and we do not need this anymore. See how concise the code became. Let's test this. Same result. Though using execute is suitable for creating multi-threaded applications, there is a drawback with this method, which is this method cannot return a value. And the reason is that execute accepts an object of type runnable. Runnable has a run method which does not return any value. A solution to this lies in the executor service class. Here is a method submit. If you look at its description, it clearly says that it can return a value. And the reason that it can return a value is because it accepts an argument of type callable. If we look at callable interface, then it has a method call which returns a value. Now, submit is not defined in Executor, it is defined in Executor Service Interface, which is a child interface of Executor. So, we need to change this to Executor Service. Otherwise, we will not be able to call submit. We don't need this anymore. Call submit on Executor Service. Here we need an object of type callable. So, create a new class that implements callable and its call method. Note that the return type of call should be the same as a generic type of callable. So, these should match. Return a value from call. Supply an object of task here. Assign the return value from submit to a future object, since call returns a future. Remember that the generic type of future should also be the same as the return type of call method. To get the value contained by a future object, use its get method. Handle the exceptions thrown by get. We don't need this anymore. Run the program. Look, we got the value returned by call. Since callable is also a functional interface, we can represent the implementation of its call method as a lambda expression. Call does not accept any argument and returns a value. In this example, we are returning 1. So, a lambda expression with empty parenthesis followed by 1 can be assigned to callable. A value returned from a one-liner lambda expression does not require a return statement. This can be directly supplied to submit. We can now remove this. Works fine. Get method of future blocks further execution till the result is not available. To show this, add a delay of 3 seconds to call method. Print a message that will execute after get. Run this. Look, the value from get and message appeared after a delay of 3 seconds. You might have noticed that after the execution has finished, the program is not terminating itself and I have to manually stop it all the time. Let me show you by running it. Look, all the threads completed, but the program is still running. This is because the executor service keeps on running in the background, waiting for the new task. To stop the executor service, once our tasks are completed, we need to call its shutdown method. Run the program. Look, it stopped. Another method is using shutdown now method. This also works. But why two methods? There is a difference between these two. Let's look at the documentation of these. There are a couple of differences. While shutdown waits for the already submitted task, shutdown now tries to stop currently executing task, and we will see that in a second. Second difference is that shutdown now returns a list of tasks that are waiting for execution or which have not yet started execution or are in a queue, while shutdown returns nothing. You can see that the return type of shutdown is void, while that of shutdown now is a list of runnable. One similarity between these two is that both do not allow execution of any task after they are called. So let's call execute after this. We have got an exception. Try this with shutdown as well. Same result. Now let's see how shutdown now tries to stop the executing task. Just add a delay here to simulate a time-taking task. Look, the task completed normally after shutdown was called. Now look at the behavior of shutdown now. We get an exception. And this is because shutdown now tries to stop the executing task, and it does this by interrupting the thread. And hence we get an interrupted exception. Now, you can see that as soon as I start the program, the message written after execute prints first. This is because the task provided to execute runs in a different thread. So, this code executes in a different thread and these lines in a different thread. What if I want this line to execute only after this thread has finished? A common scenario is you are performing some calculation in new thread and displaying the result after it. It makes no sense to display the result till the calculation has finished. For this, the executor service provides await termination method. This method takes two arguments, the amount of time that we want to wait and the time unit of this amount, for example, milliseconds, seconds, minutes, etc. If you look at its documentation, it says blocks until all tasks have finished execution after a shutdown request or the timeout occurs, whichever happens first. So, this thread is taking 4 seconds to execute. If I want to wait for its completion, then the values here should be 5 seconds. Await termination throws an interrupted exception, so we need to handle it. Change this to shutdown, else it will straight away throw interrupted exception. Run the program. Look, first our thread completes and then the main thread. Now, if I change this to 2 and run it, the main thread completes before the new thread. This is because the timeout of 2 seconds occurs before the time taken by the thread. That is all for this video. Hope it was helpful.